Hello everyone. So this is going to be what I think is going to be a pretty short video here. So all I want to do on this video is I want us to use significant figures and do a multi-step calculation to figure out what the final answer should be according to Sig Figs. So I'm going to do two separate problems here. Here's the first problem. I'm going to add a little piece of information that's not obvious just by looking at this. But we're going to say that this 2 is an exact number. Remember, that means that it has infinite sig figs here. So the overall strategy whenever we do this type of thing is we're going to always break down our calculations into either an addition-subtraction process, and we're going to follow sig fig rules, or it's going to be a multiply-divide process and we're going to follow sig fig rules. So we always do those one step at a time anyways mathematically, and so we're going to just track our sig figs, and you'll see what I mean by that. So when I look at this problem, I see 4 sig figs on this top number here, and then I see 2 sig figs on the 3.4. And remember, when you're doing addition, you care deeply about the location of the most precise decimal. And so I have the tenths place here. I have the tenths place here. I happen to have the hundredth and thousandths place on this number, but I'm going to be limited in this addition to just the tenths place. Now, when we do our math, we're only going to want to round one time. So I'm going to show you my calculator work here also. All right, so let's go 2.101 plus 3.4. And I'm seeing this number that it's implying, the focus isn't great there, but it's implying that I have 4 sig figs on this answer, and I need to keep track of that myself. I should only have a number that's good out to the tenths place. So what I like to do is I'm going to write 5.501. I'm not going to round this. I put little marks underneath the numbers that are currently significant. Okay, so if I were to rewrite this, then I have a divide by 2, and I'm still going to have minus this number over here. So now mathematically what I would do is this step. Again, I have this infinite number of sig figs on this exact number of 2. So if I bring my calculator back into the picture here, again, I apologize for the focus on that. I wonder if I can get it to pick up a little higher. All right, it is what it is. So I'm going to divide it by 2, and you see that it looks like I'm gaining sig figs, but again, I'm not. I cannot be limited by this number because it has infinite sig figs, so now I'm down to 2.7505, but in the division, I have this number, even though I'm showing 4 digits, it only has 2 digits that are significant. So this is a number, a full number, that only has 2 digits of significance divided by infinity. We are infinite sig figs. We are limited by the top number, so this can only have 2 as well. And notice I'm still not going to round this number. And then I have this subtraction that I need to do. So now I'm going to come over here and I'm going to subtract. Yeah, still not working great for me. I'm going to subtract 2.62 from this number, and here's my answer is 0.1305. So 0.1305. But on the subtraction process, so even though I have all this extra information and I don't want to lose that info, this is only significant to the tenths place. This number over here is significant to the hundredths. That's great and all, but I am limited by the tenths place here, and I do have the tenths place here. This is only good to the tenths place because that's the rule behind addition and subtraction. So my final answer on this number here is going to be limited to the tenths place. And after all of this math that I did all the way up here, this is going to be my final answer on this particular one. Okay? So again, that was just one step at a time. Here's another one. Okay? This has fewer steps. You know that I need to do some math down here in the denominator before I can carry out the division step. So this is a subtraction. This might be a realistic situation if you were doing, for example, a density problem. This might be two volume measurements. Maybe you're doing a displacement method. And so I'm going to have to do some subtraction here, and then maybe this would have units of grams or something. Obviously, I'm leaving all of that application out. Again, I'll show you what it looks like. We can do this in our head, hopefully. But if I want to see what my calculator is going to report, it's going to show me this 0.5 number. Now, I need to be careful with this because this is 3 sig figs. That's good out to the hundredths place. This is 3 sig figs, good out to the hundredths place. My calculator is showing something that appears like it's only good to the tenths place. But I know that I still have to be good on the hundredths place here. So I'm going to rewrite this, 14.29 divided by, putting my 0.5, that's what my calculator says, but I actually am good out to this digit as well. And so I still have two significant digits right here. Remember, in the subtraction process, if I have the hundredths place on both, I have to still have it when I'm done here. Okay, so now I have one final calculation to do. This one would be a little trickier. Well, I guess not too bad to do in your head, just doubling it. Here's my number that we have, so I'm just going to write it down, 28.58. This time I'm doing a division process. This is 4 sig figs divided by 2 sig figs. I'm limited by the 2 sig figs that are right here. So I'm only going to round once at the very end of my problem. This 0.58 is going to kick me up to 29, and I am reporting 2 sig figs for that final answer there. Okay, so if you think about the vast majority of the problems that you're going to be doing, they are things that are either going to be a series of addition, subtraction steps or multiplication, division steps. Their logarithms are a little bit different, but generally we're not going to need those for a little while, so I'm going to leave it at that. All right, you should be able to take your next shot and try a few sample problems now.